First question in St. John's assignment sheet. Find the greatest length of steel wire that can remain hanging vertically without breaking. The breaking stress has been given. That's for steel. So it's a steel wire and greatest length it can extend up to. The stress is equal to force by area. Force is m into g. Mass is density into volume. Volume is area into length. So writing like this, A get cancelled. You get a new formula for the stress to be rho Lg, and therefore from this length is equal to stress by rho g. Stress has been given, density has been given, gravity is 10, take it as 10, so you get the length. That's the maximum length to which it can extend up to. Let's go to next question. Consider a rod of steel having radius 8 mm and length 2 meter. If a force of 150 kilonewton stretches it along its length, calculate the stress percentage strain in the rod. The elongation in length is 7.46 mm. So then I know that stress is equal to force by area. And I know stress is equal to force by area. Force is given. Area is also cross-section area itself is given. No, I have to find area by using the formula pi r square. Radius is given millimeter, converted to meters by putting it to 10 to the power minus 3. Pi r square, so 8 into 10 to the power minus 3 the whole square into pi, and you get this value. Just plug it in. You get the stress. The first question is answered. The percentage strain is change in length by original length into 100. Change in length, you've just there's been given elongation of the length is 7.46 millimeter in the question into 10 to the power minus 3 meters by original length. It's a 2 meter wire into 100%. 100% will give me the percentage, and that's about this. Consider a solid cube which is subjected to a pressure of 600 to the power 5 Newton meter square. Due to this pressure, each side of the cube is shortened by 2%. Find out the volumetric strain of the cube. Since the length of the cube is shortened by 2%, just find the final length by writing it like this. I always do this as the first step. Get the final length, L minus 2 by 100 into L. Then the volumetric strain is delta V by V, which is change in length by original length. Change in length is initial length minus final length. The whole cube, because everything is volume, change in volume by original volume, L cube minus L cube into 98 by 100 the whole cube, L dash. It's L cube minus L dash cube by L cube. Just substituting this value. You have to insert a negative sign to show that there's a strain is a decrease in volume. And so percentage means you just multiply it with 100%. So that's about it. A cable wire is replaced by another of same length and material but twice the diameter. How will that affect the elongation of the wire under given load? So load is the same, and load is pressure is equal to force by area. Force is the load is pressure into area, thus force is proportional to A. So load initial is pi r1 square. The load final is pi 2 r1 the whole square, because the diameter is getting twice. So radius is also getting twice, 2 r1 the whole square. So this is 4 times the initial load. Okay, so let's go to next. How much pressure should be applied to decrease the volume of the water to compress it by 0.01%? Given the bulk modulus of water has been given. So bulk modulus is force by area, which is change in pressure here by change in volume. Change in pressure, delta P, stress itself is delta P by delta V by V. So first what are you doing is like it's compressing by 0.01%. So initially find the new volume, and once you find the new volume, this is a new volume, you have to do, but the change in volume itself is given. The decrease in volume, which means the delta V itself is given. I'm sitting and finding here delta V again. What is given in the question itself is so much. It's V into 0.01 by 100. That's what has been given. So I don't have to necessarily do so much. This is not required. So you understand all this is unnecessary. What has been given itself is delta V. If you can understand that, 0.01 by 100 into B is the change in the volume. So now, by original volumes, if you do that, B and B will get cancelled. So you can plug that value in here. And hence find delta P, cross multiply and find delta P. Bulk modulus has been given. So that's the question. Two wires A and B are made up of same material. The wire A has length L and diameter D, while the wire B has 2L and diameter D by 2. If the two wires are stretched by the same force, which means, force is the same, okay. So find the ratio of the elongation. So X modulus equals stress by strain, force by area by delta L by L. You get this formula. So from this cross multiply, write delta L and write it for the first material and second material based on the diameters. And you know that the diameter of the second wire is D by 2 times the original. So instead of writing D dash new diameter, I'm writing D by 4, which becomes D square by 16. Okay, just cancel and get the value, and that will be the ratio of change in length of the first wire by change in length of the second wire. The breaking stress of a wire depends only on the material, because breaking stress for steel, breaking stress for every metal has got its own breaking point. Okay, so then that's about it. Let's go to next. A wire can sustain a weight of 20 kg before breaking. If a wire is cut into two equal parts also, each part can sustain a weight of the breaking stress does not change. The breaking stress is always a given value, which is 20 kg. It's a material constant. So a rope 1 centimeter in diameter breaks if the tension in it exceeds 500 newtons. The maximum tension that can be given to a similar rope of diameter 2 centimeter. Force is proportional to area. P is equal to F by A, F is equal to P into A. Force is always directly proportional to area. So F is proportional to pi r square, but substitute diameter as D by 2. So still F is also directly proportional to D square. So tension is proportional to D1 square, tension is proportional to D2 square. Divide it, you get it like this. Substitute the tension's value D1, D2 you don't know. D1 and D2 you know, substitute it and get the answer. A load of 10 kg is suspended by a metallic wire of 3 meter long and cross section area has been given. Find the stress developed. Stress is Young's modulus into strain. Oh, the stress we cannot find now because they've given original length, but they've not given change in length. Let's find the elongation using this formula. Delta L is the elongation. The rest of the values have been given. Just plug it in. Get delta L. And if they ask you for stress, let's look at it. This force by area. Force is 10 kg load, which is 10 into 10. By area itself is cross section area 4 millimeter square, which is 4 into 10 to the power minus 6. So then thus you can calculate the stress also, correct. So let's go to next sum. In the given figure, the upper wire is made up of steel, the lower wire is made up of copper. The wires have equal cross section area. Find the ratio of longitudinal strain developed in the two wires. Young's modulus of the wires have been given. Longitudinal strain is delta L by del L for steel and delta L by L for copper. Just divide it. Knowing the value of Young's modulus, you can directly answer. The lower surface of a cube is fixed on the upper surface, which means it's shear stress. The force is applied at an angle of 30 degree. Theta, you know, the change will be, there will be a change in shape, nothing else. In the shear stress, whatever is like this is going to become like this. Just a change in shape. A rectangle will become a parallelogram, or a cube will become a parallelepiped. Okay, anyway. A metallic cube of size 10 centimeter is subjected to a shearing force of 300 kgf. The top face is displaced to 0 point. The parallel displacement has been given. Tan theta, you can find this, therefore you can find this gap to be 9.75 since you know the other displacement. And tan theta is opposite by adjacent, and opposite 0.25 by adjacent is just 10. Why do you have to find this? I don't understand why did I even find that. I thought of doing it some other way. So then shear strain is theta, which is change in length, displacement in the opposite side. Opposite by adjacent. Tan theta is what is called the shearing strain. So if anybody has any dispute, you can ask me. This is my way of doing the sums. 14th question, the modulus of rigidity of a liquid is 0. Because liquid has no fixed shape, it cannot offer any resistance to shearing force. The modulus of rigidity is therefore 0. So next, let's the shear strain graphs for two material A and B have been given. Can you see first one has got a steeper slope stress strain curve, therefore it's got greater X modulus. Whereas the second one is not very steep when compared to A. The diagram in your question paper is not clear. I served the net and followed the proper diagram. Next question is, which material is more ductile? Material A is more ductile. Which material is more brittle? The material B is brittle because it doesn't have well-defined plastic region. Which of the two is stronger material? So you know that A will be a strong material. B breaks immediately, right? The load versus elongation graph for four material has been given. Which is thickest wire? Thickest wire is where the force applied has to be more, and the load applied is greatest for D, and so that's about it. So it was pretty easy.